Welcome to Electron 6 here, and you are watching Signal System lecture series. And today the topic of discussion is the stable versus unstable system. Okay. A system is called stable if it satisfies the Vivo criteria. What is Vivo criteria? It is the bounded input, bounded output. If for uh, any bounded input signal, the output of a system, if it produces the bounded output, then it is called the stable system. Okay. For any input signal which is bounded, if it produces the unbounded output, then it is called the unstable signal. Okay. So let us get into details the difference between the stable and unstable systems. So as I have told you, a relaxed system which is said to be stable if and only if every bounded output produces bounded output. Okay. So what do you mean by this bounded? So bounded means the input signal or any input or output signal must be finite amplitude. Okay. At every instant of time. Okay. If at any instant of time the amplitude goes to infinity, then it is not bounded. This is unbounded signal. Okay. So bounded means the input or output should be finite in amplitude at every instant of time. That is the called the bounded signal. Okay. So if it satisfies the Vivo criteria, then it is the stable systems. Okay. So you can see over here. Suppose a discrete time signal, that is the input is x of n and output is y of n, are bounded mathematically means that there are exist some finite numbers. So you can see the amplitude is means finite. Mx and my is finite for all n. Okay. If the amplitude is finite for input as well as the output, then it is satisfying the Vivo criteria, and the system is called the stable systems. Okay. So for continuous time, only the n is replaced by t. Okay. So mx and my is the mx is the means it is the input. Okay. This mx would be finite numbers as well as the mi would be finite numbers for output. Okay. So if this satisfy, then it is a stable system. Okay. So let us check. For a stable system, the bounded input produces the bounded output. If the bounded input produces the bounded output, then it is the stable system. Okay. For unstable system, suppose this x of n is the input signal, which is means that is the bounded input, and it is producing the bounded output. Then it is the unstable systems. Okay. So for any bounded input, if it produces the unbounded output, it is called the means unstable system. Okay. So let us check with examples. Okay. So these are the bounded signals. Okay. Bounded signals. This DC signal is a bounded signal. DC signal means this is the constant signal. Suppose 5, 10, 15. These are the DC signals. Sin t cos t. These are varies between +1 means -1 to +1. Okay. So this is the amplitude varies between -1 to +1. So at every instant of time, it is the finite amplitude. So that is why these are the bounded signals. Ut you can know ut is a, or un is a bounded signal. So un equal to actually or ut equal to 1. Okay, for t is greater than equal to 0. Okay, so at every instant of time the value is 1. So it is not going to infinity. That is why the signal is bounded signal. So these we will apply as input signal and check whether the system is producing the bounded output or not. Okay. So let us that. So to test the system, if it is stable or not, we first apply the bounded signals as the input. Okay, and check whether the output is bounded or not. If the output is bounded for the bounded input signal, then the system is stable. If it produces the unbounded output, the system is unstable. Okay. So we will check these problems one by one. Okay. These are the some discrete time and the continuous time as well. So whether the systems are stable or unstable. Okay. So first thing here x of n minus 5. Okay. So let us means provide some input. Okay. So x of n, to test the signal is bounded or not, we are means providing a bounded input. Okay. So u of n is a bounded input. So let us check by providing the bounded input as u of n. Okay. So it will be y of n equal to u of n minus 5. So u of n minus 5 is the signal which is delaying x of u of n. So it is produced by delaying u of n by 5 units in time, u of n. Okay. So this is our means delay means right shift. Okay, this is the right shift of the U of n. So U of n, if we right shift U of, this is U of n. So this is 0, 1, 2, likewise. So this is U of n. So we are right shifting U of n by 5 units in time. Okay, so this is 3, 4, 5, 6, likewise. Okay, so you right shifting U of n by 5 units of time. So this is your U of n minus 5. So you can see in this U of n minus 5, the amplitude is your 1. So it is always amplitude is 1 because it is a unit step signal. So it is never goes to infinity. Therefore, it is producing the Weber or satisfying the Weber criteria. Okay, so and the system is stable systems. Okay, so let us check our second example case. So x of n minus of x of n1 plus 5. In this case also, we are applying the test signal as u of n. Okay, so this is a ui of 1 n equal to u of n minus of u of n plus 5. So this is our u of n. So u of n plus 5 is obtained by advancing x of n by 5 units of time. So it will start from minus 5. Okay, so you can see over here, this is the minus 5. Now we will subtract u of n. Okay, and this is we are subtracting u of n plus 5 from u of n. Okay, so let us check this. So you can see over here. So this is our minus 5 also. So because minus 5. So at this place, the minus 5, this is 1. So 0 minus of, this is the amplitude is 0. In this case, the amplitude is means 1. So 0 minus of 1, similarly, minus 4, the amplitude is 1. Minus 4, the amplitude is, sorry, minus 4, the amplitude, in this case, the amplitude is 0. In this case, the amplitude is 1. So 0 minus 1, that will be 1. So up to this minus 1, it will be minus 1. Then at 0, it will be 1 minus 1, it will be 0. Okay, so you can see over here, this is your u of n minus of u of n plus 5. So you can see over here also, the amplitude minus 1, it is not going to means infinity. So it is a finite number. Okay, so in this case also, it is satisfying the Weber criteria and the system is stable systems. Okay, so let us check out this case. So x of t, this is a continuous time signal. So x of t, let us means test as a DC signal, it is 5. So x of t equal to 5 means y of t will be 10. So you can see y of t is a, means it is the uh, finite number. Okay, so it is satisfying the Weber criteria. Therefore, the system is a stable system. So it is a fourth case, y of t equal to x of t sine omega t. So let us apply the test signal. X of t is a u of t. Okay. Now you can it will be u of t sine omega t. So u of t value is 1 from 0 to infinity. Okay. So it is the, so you can write as from 0 to infinity, the it will be sine omega t because u of t equal to 1. In the sine omega t, you can see the value is your the amplitude is minus 1 to 1. It can vary from minus 1 to 1. Okay, so it never goes to infinity like this. So these are the finite numbers. So this is that is why it is also satisfying the Weber criteria. Okay, and the system is stable systems. So let us check our this case. So here also y of t is the integration of x of t. So x of t we are applying as a unit test, a unit step signal, it's a test signal. So integration of u of t dt. So it will be a unit ramp signal. Okay. So r of t. So what is r of t? R of t equal to, it is not the means it is not the I mean satisfying provocator because you can see r of t equal to this one. Okay. So r of t equal to t for t is greater than 0. Okay. So that is why it is goes to infinity. You can see. So r of t is not the means bounded signal. So therefore the output is unbounded. Okay. So the output is unbounded for bounded out input. Okay. So that is why the system is a constant unstable systems. Okay. So this system is the unstable system. Okay. So likewise, so y of t equal to d by dt of x of t. Okay. So x of t, let us check by applying the test signal u of t. So y of t equal to d by dt of u of t. So it will be a del of t. So del of t is a unit impulse signal. Again, the unit impulse signal is also not means bounded signal because you can see at t equal to 0, the this value goes to infinity. Okay, and all the values are 0. Okay, this is I am talking about the continuous time signal. So this is our del of t. Okay, so that is why in this case also the system is not stable. Okay, so the output is not producing the bounded one. So that is why the output is unbounded for the bounded input. So this system is unstable system. So let us check our last case. There is t into x of t. So let us apply the test signal as u of t. So u of t equal to t into u of y of t equal to t into u of t. So t into u of t equal to r of t, which is a ramp signal. So ramp signal is not produces the is not producing the bounded output. Okay, so that is why it is the system is not stable. Okay, the output is unbounded for the bounded input. So I am providing the bounded input, but the output is unbounded. So that is why the system is unstable systems. Okay, so likewise you can test whether the system is bounded, means input for bounded input, and the system is producing the bounded output node. If the system is producing the bounded output, then the system is stable. If the system is producing the unbounded output, then the system is unstable. Okay. So thank you for watching this video. If you have any doubt, please free to connect me in the comment section. Okay. So thank you all. Have a nice day.